Hello there and welcome to AS Maths. We're on a graph drawing, massive long video that just goes through question after question, hopefully building up those skills for graph drawing as we go through. So there are two main ways that you can draw complicated types of graphs in AS Maths. We've got the polynomial way and we've got the graph transformations way. We're going to start on a bunch of questions to do with the polynomial method and then we'll work on some graph transformations afterwards. So this is our first graph. Let's dive right into it. We've got y equals x minus 4, x plus 2. What you might sometimes get is you might get the pre-factorized version. You might have to factorize it to get this, but it's really easy to draw a graph once you've got this equation here. Let's first look at what type of graph it will be. If we expand the brackets, it's going to give x squared minus 2x minus 8. And the most important part of this expansion is the x squared part. So we know it's going to look like an x squared. So the first part is going to look like y equals x squared. It might be moved around a bit, it might be squished a bit, but yeah, it's roughly y equals x squared. The second thing we look at is where are the x-axis intercepts. And the x-axis intercepts are where the brackets will be made effectively 0. Whenever we cross the y-axis, whenever we cross the x-axis, it's the y component that equals 0. So if we want 0 to equal x minus 4, x plus 2, we just solve this equation. X equals 4 and x equals minus 2. So we know the graph is going to cross at minus 4, so plus 4 and minus 2. We also need to look for the y value, the y-intercept, so that's going to be when the y-axis, it's going to be where it crosses on the y-axis, and where it crosses on the y-axis is when x is equal to 0. So if we replace x with 0, 0, 0, we get minus 4 times 2 is minus 8. So it's going to cross at minus 8. So let's now draw the answer. It's going to cross at 4 and minus 2. It's going to cross on the y-axis at minus 8. And it's going to be a perfectly symmetric x squared graph. So it's going to look something like that. So it's going to be slightly shifted to the left, it's going to be more weighted to the left-hand side. That's because if you look at the roots, we have minus 2 and 4, and the midpoint is going to be where it reaches its minimum point. So it's going to be slightly shifted to the right, going through minus 8 on the y-axis and minus 2 and 4 on the x-axis. So, first of all, you look at what type of shape the graph will be. The next thing you do is solve the equation when it's set equal to 0, so in this case x needed to be 4 or minus 2, and then kind of expand the brackets at the end to give you your minus 8, or treat x as the value 0 and then just multiply out all the brackets. Okay, let's move on to the next one then, slightly more difficult. So what type of shape graph will this have? Well, it will have an x cubed shaped graph. The next thing we need to know is where it will cross the x-axis, so that will be at minus 2, 4 and 7. Those are the solutions to each of the brackets. And then where's it going to cross the y-axis? Well, if we treat all of these x values as 0, because that's when it will cross the y-axis, we're going to get 2 times minus 4 times minus 7, which is going to give us 28, 56. Positive 56 because we've got two negatives in there. We're not multiplying the solutions for x together, we're multiplying together what the actual values are of the numbers inside the bracket. So 2, minus 4 and minus 7. If you were to expand all these brackets, you would get positive 56 at the end. So what does an x cubed graph roughly look like? Well, it roughly looks something like this. You should know that from just knowing what your standard graphs look like. So it's going to start down the bottom right. It's going to go through minus 2. It's going to go through 4 and it's going to go through 7. It's going to go through 56 up here. So let's start to draw things in. So there we are, that's the answer to this question here. And what we should probably do is we should probably label the intersection of all of the axes. And there we are, perfect answer. Okay, let's move on to the next one then. So, starting on what type of shaped graph it's going to be. Well, it's going to roughly be an x cubed shaped graph when we expand the brackets. The next question is, what are the x solutions? So -3, -1, and 4. And then the next one is, what's the y-axis intercept? Well, if we were to expand the brackets, that would take quite a while, or we could just treat all of the x values as 0, and it would be 3 times 1 times -4, that would give us -12. So let's now draw the graph. It's going to be a positive x cubed graph going through -3, -1, and 4. It's going to start down here and go up, down, up. Oops, okay, slightly to the right hand side, this curve here should probably be a bit more like that. But there we are, that's the answer to this question. And it will go through at -12 down here. Right, moving on to the next one. So, again, what type of shaped graph will it have? Well, if we expand all the brackets where x are, it's going to be x cubed. That's going to be the rough shape of the graph. The next thing we need to do is find out all the solutions for x. So it's going to be 4 minus 2. And what does this x on its own mean? Well, that means that it could potentially be the 0 solution. Think of it as the bracket x minus 0. That would just be x, wouldn't it? So x is your solution there. Alternatively, if you've got x is 0, 0 times anything will give you 0, which is what we're effectively looking to solve this equation to be. And then the final one, the y-axis intercept, well, this is going to be effectively 0, so it's 0 times -4 times 2, well, that's just going to be 0. So let's draw all of these coordinates first, so 0, 0, -2 and 4. It's going to be an x cubed shaped graph, so it's going to start down here, come up, down, up. Lovely. Now that you're getting into the swing of these, try and do it with a bit of speed to it. You shouldn't take too long, and you should kind of automatically be able to do these in an exam. Okay, moving on to the next one then. So, think of this as x plus 3, x plus 3, x minus 3. So, what solutions, what type of graph do we have? It's a y equals x cubed shaped graph, roughly. The next part is, what are the x solutions? Well, it's going to be -3 and 3. But the extra bit of information on this is that we have the -3 root appearing twice. So this is going to be what we call a repeated root. And the next one, so what do we get when we expand the brackets? -27. Okay, so let's plot those coordinates on the graph. It's going to be at -3, 3. And let's show you how we deal with this graph when it's a repeated root. We know it's going to go through at -27. So it's going to go up to the -3 point. And at the -3 point, because it's a repeated root of the squared type, it's going to look like an x squared graph at that point. So it's going to look like that there. So this is what an x squared repeated root looks like. Why am I writing x squared repeated root? Because it's x plus 3 squared. So it's a squared type repeated root. So if you just circle in on this region here, it looks like an x squared graph, kind of upside down, but that doesn't really matter. So yeah, so this is what the graph looks like. Lovely. Okay, have a go at the next one then. So let's start with, it looks like an x cubed shaped graph. It's got solutions at x equals 5, 1 and 1, or 1 repeated. It's going to have, it's going to look like x minus 5, x minus 1, x minus 1. So the y-axis intercept is going to be at -5 times -1 times -1, that's -5. So let's now draw the graph. So it's going to be an x cubed shaped graph. It's going to cross at 5 and repeated at 1, and it's going to go through an intercept at -5. So it's It's going to go up to this point here, touch it, come back down, and then go back up through it there. So it's an squared type repeated root at this point here. Repeated root of the x squared type because it's x minus 1 squared. Right, so there we are, that's the answer. Let's move on to the next one. So, we've got a negative symbol at the front of it. So, what would be the rough shape of this graph? Well, when we expand all the brackets, it's going to be minus x plus 2, x minus 3, x minus 3. So the rough shape of the graph is going to be a minus x cubed graph. That will mean that it will start on the top left and finish on the bottom right when we draw it out. So the next point is going to be the x solutions. They're going to be at minus 2, 3 and 3. And then the next part is going to be the y-axis intercept. So if we expand the brackets, 2 times minus 3 times minus 3, that would be plus 18, but we do have the minus at the front, so it will actually be minus 18. So let's now start up here because it's a negative x cubed graph. We're going to intercept at minus 2 and 3 twice. We're going to go through minus 18 down here. So it's going to go through there, up, hit the 3 and back down. Lovely, good. So it goes straight through the minus 2 and has a repeated root at 3 because it has a x minus 3 squared on this bracket. Lovely, good. So let's move on to the next one. So once again, let's think about what type of shaped graph we have. It's going to be 4 minus x, x plus 5, x plus 5. So if we expand all the x's, we're going to get minus x cubed. Next one, so what do we get on the x-axis intercept? So the x-axis intercepts are going to be 4 for this one here because that's the x value that will make the bracket 0, and minus 5. Minus 5 twice. The next one is to think about what the y value will be when it's expanded. So let's expand all the numbers. 4 times 5 times 5, that's 100. So let's think about what the graph's going to look like. It's going to start on the top left because it's a negative x cubed graph. It's going to go through at minus 5 twice and then at 4. And it's going to finish down here and it's going to go through at 100. So it's going to start down here and it's a repeated root at minus 5. So it's going to touch it and come back upwards. Then intersect 100. Then go down straight through the number 4. Okay, so there we are. So we have a repeated root here at minus 5. That's why it looks like this. Right then, let's have a go at the next one then. So first of all, what type of shaped graph is it going to have? Well, it's going to have a 3 minus x, 3 minus x, x plus 2 solution. So it's when we expand the x's, we're going to get minus x times x. That will give us positive x cubed. So we're back to positive x cubed. The x-axis intercepts are going to be at 3, repeated, and minus 2. And where's it going to intercept the y-axis? Where it's going to be at 3, 3, 2. So it's going to be 18. Because you think about what when the x value is 0, what's the answer going to be? So let's expand the brackets. No, let's draw the graph now. So where's it going to start? It's going to start on the bottom left. It's going to go through at minus 2, all fine. It's going to go through 3 as a repeated root, and it will go through at 18. So let's start to go through there, up, down, touch, up. So there we are. So this is the shape of the graph, repeated root at this point here, because it's 3 minus x squared. Right then, so moving on to the next one, a little bit more difficult this one. What type of shaped graph is it going to have? It's going to have a power of 4 type graph. So x to the power of 4 will be the rough shape of the graph. The x to the power of 4 graph looks roughly like this, although it could potentially look like this. So moving on to the next part, what are the x-axis intercepts? The x-axis intercepts are going to be at 0, 3, so -3, -2, and 4. The y value is going to be 0 times 3 times 3 times -4, and because we had a 0 in there, it's just going to be 0. So let's draw this graph then. It's going to go through at 0, -2, -3, and 4. It's going to go through a y-axis point of 0, and then we draw the x to the 4 graph there. So it's going to start on the top left and finish up here for a positive x to the 4 graph. So let's go through down, intersect, up, down, and up, finish up here. Lovely, there we are. So that's the answer to this question. Let's move on to the next one. So it's going to be y equals x to the power 4 roughly as the graph. The x-axis intercepts are going to be at -2 as a repeated root, 3 and 7. The y value, the y-axis intercept is going to be 2 times 2 times -3 times -7, 2 times 2 times -3 times -7, well, that's going to be 4 times 21, so 84. Right, okay, let's now draw the graph. So it's going to go through at -2 as a repeated root, intercept at 84, then it's going to go through again at 3 and 7. That's not very close, is it? 7 will probably be over here. So it's going to start up here, it's going to touch the x squared, so it's going to touch the -2 value because it's repeated. It's going to come back up through 84, down through 3, then back up through 7. Lovely, there we are, so that's the answer. Moving on to the next question, so it's going to be y equals x to the power of 4. What are going to be the x value solutions? Well, we're going to have a 0, 2, 3, and a -2. The y value is going to be 0 times -2 times -3 times 2. Because we had a 0 in there, it's just going to be 0. So it goes through at 0, 2, 3, and -2. And it's going to start on the top left and go down through here, up through here, down through here, up through here. Lovely, so there we are. It doesn't have to be perfectly symmetric. The gap between here and here is 1, so it's not expecting to go very low here, but the gap between here and here is 2, so you'd expect it to go deeper in this section here. Right, then let's move on to the next section. Ooh, a little bit more difficult here. So what type of graph is it going to be? Well, it's going to be roughly an x to the power of 4 graph. We have a square here and a square here. The x value solutions are going to be 3, 3, -4 and -4. So 3 repeated and 4 repeated, -4 repeated. And what do we get when we expand the brackets? Well, we're going to have -3 times -3 times 4 times 4. So that's going to give us 144, so you can couple them up into 12s. Okay, so it's going to start up here. It's going to go through -4 as a repeated root. It's going to go through 144, and it's going to go through 3 as a repeated root, and then finish up here. So it's going to go through touch, through 124, down to 3 touch, and up to a finish. So these are what we called x squared repeated roots. Reason being is that locally, or around the -4 coordinate and the 3 coordinate, it looks like an x squared graph. So it's similar to the type of brackets that we have. Oh, sorry, it's got the other way around, but you can see it's the square that I'm highlighting here. Right, so a little bit more of a complicated type of repeated roots that we've got here. So this question is going to be an x to the 4 graph. The next one is going to be x equals 3, 3, 3, and -1. So this is a tripled repeated root. I like to call this a cubic repeated root. Okay, and the y-axis intercept is going to be -3 times -3 times -3 times -1, so times +1, so that'd be -27. So what's this graph going to look like? So it's going to go through at -1, all fine and normal, and then it's going to go through at 3, and then it's going to intercept at -27. So again, it's x4 to the graph, so it's going to start up here and finish up here. So it's going to go down, down, and then start to come back up. Now, this is going to be a cubic repeated root. So what that means is that the coordinate 3 is going to look like an x cubed graph. And an x cubed graph, remember, looks like this. So this is going to be the type of turning point or the type of repeated root that this graph is going to have. This is a cubic repeated root. So it's going to go up to it, do a little squiggle, and then head back up towards the finish. So this here is what we call a cubic repeated root, because if you just look in this region here that I've highlighted, it looks like an x cubed graph. This is a cubic repeated root. Alright, then moving on to the next question. This question is y equals minus x plus 2 squared, x minus 4, x plus 3. So what's the dominant curve going to be in this graph here? Well, if we expand the bracket, it's going to be x to the 4, but there's a minus at the front, so it's going to be minus x to the 4. The roots are going to be minus 2, and that's going to be a quadratic repeated root, 4 and then minus 3. And then what's the y-axis intercept going to be? Well, it's going to be 2 times 2, let's grab a calculator, 2 times 2 times minus 4 times 3, but then it's the negative of that, so it's 48. Okay, so let's get started on the drawing of this graph. So it's a negative x to the 4 graph, so it's going to start down here and finish down here. Okay, so it's going to go up through minus 3, and then it's going to hit minus 2 in a quadratic style, and then it's going to come back down through 4. So let's start drawing the graph then. So it's going to go up straight through minus 3, it's going to be a quadratic at minus 2, and then it's going to go down through 4 and then finish down there. And it will have a y-intercept here of 48. And there we are, that's the answer to this question. Okay, let's move on to the next one. So in this case, it's going to be a y equals, expand the brackets, x times x times x times x, but there's a minus in front, so it's going to be minus x to the 4. The roots are going to be minus 1, 2, 2, and 2. The y-axis intercept is going to be 1 times minus 2 times minus 2 times minus 2, and then times the minus at the front of the bracket, and that will give us 8. So let's start drawing the graph now. It's going to go through minus 1. It's going to go through 2 in a cubic style. This is now going to be a cubic repeated root. And where's it going to start and finish? It's a negative x to the 4 graph, so it's going to start down here and finish down here. So let's go straight up through minus 1 and then do a little cubic wiggle through the 2 repeated root, and it's going to intercept the y-axis at 8. And there we are, that's the answer to this question. Okay, let's move on to the next one. So this one's going to have a rough shape of y equals, well, x times minus x times minus x times minus x, that's minus x to the 4, triple negative there. The roots are going to be, well, the first one is going to be the x value that makes this bracket equal 0, that's minus 3 over 2. The next one is going to be 4, and then another 4, and then another 4. And the y-intercept is going to be 3 times 4 times 4 times 4, 3 times 4 times 192. Okay, so let's now start drawing the graph. So x-intercepts at minus 3 over 2 and 4 as a repeated root. It's a negative x to the 4 graph, so it's going to start down here and finish down here. And it's going to go up through the minus 3 over 2, down, do a little cubic wiggle at that point, and then down to finish. So finish at 4 and y-intercept of 192. Okay, moving on to the next one then. So let's go through all of these graphs here. So what's the type of shape of graph? It's going to be x times x times x times x. So that's a positive x to the 4 graph. The roots are going to be 5 over 3, minus a half, 2, and 2. and the y-axis intercept is going to be minus 5 times 1 times minus 2 times minus 2, that gives us minus 20. And now let's start drawing the graph. So it's going to intercept at minus 1/2, 5 over 3, and 5 over 3 is just a little bit less than 2, so 2 will go next as a quadratic. So it's going to start up here, it's a positive x to the 4 graph, finish up here. So it's going to go down through a half, back up through 5 over 3, down, and carry on going back upwards, so a quadratic style repeated root at 2, and it will intercept the y-axis at minus 20. Okay, moving on to the next one. So this is going to have a rough shape of y equals minus x times x times x. Back to cubic on this one, so minus x cubed. The x-axis intercepts are going to be 2, minus 3, and minus 3. The y-axis intercept is going to be minus times minus 2 times 3 times 3. That would be 18. So what kind of shape of graph is this going to have? Well, it's a minus x cubed graph, so it's going to start, it's going to start down here, start up here rather. It would start in the bottom left if it was normal, but it's not, it's negative. And it's going to go through minus 3 as a repeated root, and it's going to go through 2 as well afterwards. So it's going to come down, touch, down straight through it. So it's going to be at 18 and minus 3 for the repeated root. Lovely, moving on to the next one then. Right, okay, so we've got to have a look here and see whether we're going to get any roots out of this quadratic. And we can find out whether we get any roots out of a quadratic by b squared minus 4ac. If it's positive, yes. If it's 0, we'll get a touching repeated root, and if it's negative, we get no roots. So it's going to be 16 minus 4 times 1 times 19. I don't know what 4 times 19 is, but I can definitely tell you that's negative. So we get no roots here. So that means this is not going to contribute to any more x-axis intercepts. The only x-axis intercept we're going to get here is a 2 intercept. The rough shape of this graph is going to be a cubic shape graph, and the y-axis intercept is going to be minus 2 times 19 minus 38. So what's going to happen with this graph? It's going to intercept at 2. It's going to be a normal x cubed graph, so it's going to come up and do something like this. Okay, so there we are. So that's the rough shape of this graph. It's not going to have 3 roots, this one, even though it's a cubic, because this quadratic at the end here doesn't give us any roots, and we found that out by testing b squared minus 4ac. Okay, moving on to the next one. Again, let's test this thing here, b squared minus 4ac. So this is going to give us 9 minus 4 times 1 times minus 15. Well, that's a double negative, so that's definitely going to give us something positive. So what I should probably do now is type this into my quadratic polynomial solver to get my roots. So it's going to be 3 plus root 9 minus 4 times 1 times minus 15 all over 2. And we get a root here of 3 plus root 69 over 2, and the second one's going to be 3 minus root 69 over 2. So let's find out what the decimal of that's going to be, about 5.65. Oops, 5.65. And the second one is going to have a numerical value of minus 2.65. Keep on doing that, 2.65. And the other root will be at x equals 4. It's roughly going to be an x cubed shaped graph, and the y-intercept is going to be 60. Okay, so let's now draw this graph. So it's going to go through at 4. It's going to go through at about 5.65 and minus 2.65. It's going to be a cube shaped graph, so it's going to go up, down, and straight up through there. So this is kind of like the first quadratic root. That's the second quadratic root. So equals alpha 1 equals alpha 2. Okay, so there we are. That's the answer to this question. let's move on to the next one. Right, so this one's a bit easier than the previous one. So y here is going to be a rough shape of a negative quartic graph. The roots here are going to be 0, because that's what the root is when it's just x on its own at the front, -3, 2, and -2. And the y-axis intercept is going to be 0 times 3 times -2 times 2. Well, that's just 0. So let's now consider the graph. So it's going to go through at 0, at -3, at -2, and at 2. Try and make it symmetric on both sides. It's a negative quartic graph, so it's going to start down here and finish down here. So it's going to go up, down, and that's your answer. Okay, moving on to the next one. So the rough shape of the graph is going to be a negative x to the 4 graph. We've had a lot of them. We're going to have a double repeated root at 0 and a double... Ooh, what about this one here? This one's a little bit of a cheeky one. I'll probably need to factorise this one. X plus 2, x minus 2. A little bit of difference of 2 squares on that one. So we're going to have repeats. So we're going to have roots there of -2 and 2. And the y-axis value is just going to be 0 because it's 0 times -4. So the curve is going to start down here and finish down here. It's going to go through at 0 as a repeated root, -2 and 2. So it's going to go up, touched, up again, down. So pretty much perfectly symmetric, that graph. Okay, moving on to the next one. So it's going to be y equals a negative x to the 4 graph. It's going to have roots of 0, 0, 4, and 2/3. And it's going to have a y-axis intercept of 0. So it's going to go through at 0 as a repeated root, it's going to go through at 4, and it's going to go through at 2/3. And it's a negative x to the 4 graph, so it's going to start down here. I haven't done many of these positive x to the 4 graphs, they're all mostly negative. So it's going to go through touch, down again, up, down again. Lovely, there we are, that's the answer to this question. Okay, we need to test b squared minus 4ac for this one here. So b squared minus 4ac, so that's going to be 16 take away 4 times 1 times 17. And I don't know what that is, but I definitely know it's negative. So we get no roots out of this thing here. So the roots are just going to be 0 and 0. We get a y-axis intercept of 0, and the rough shape of this graph is going to be an x to the 4 shaped graph. So x to the 4 will start up here and finish up here. And as much of the graph as we need to know is just going to go down, touch, and then back up. Now what might happen is it might do a little wiggle at some point, because it is an x to the 4 graph, so it could potentially wiggle at some point. It could come down and then back up, but what we're interested in here is that it only intercepts the x-axis once as a quadratic repeated root at 0. So I'm not 100% sure that this is actually what the graph looks like, but for the benefit of our question, where does it go through the x-axis? Only once. Where does it go through the y-axis? Only once. So it's probably going to look something like this. Right then, so moving on to the next question. So what type of shaped graph is this going to be? It's going to be x to the cube. So x times x times x times minus x. That's minus x, but we've got a minus at the front. That would turn it back into positive x to the 4. The roots for x are going to be 4 as a repeated root 3 times, and then 5. And then the y at value intercept is going to be minus 4 times minus 4 times minus 4 times 5 times the negative at the front. That's 320. Okay, so let's start drawing then. So it's going to go through at 4 as a cubic repeated root, and then through to 5, and it's going to go through 320. It's a positive x to the 4 graph, so it's going to start up here. It's going to do a little jiggle through. Whoops, that's the wrong way. A little jiggle. Let's rub that one out. So it's going to go through x, through that 4 one there is a cubic jiggle, and then straight up through 5, and that's your final answer. Alright then, so we're going to move on to the second way that you can draw a shape of a graph without going through the whole roots thing. So it might be a different kind of graph with a different equation. So some standard results that we expect you to know just off the top of your head. We expect you to know the x squared shaped graph. We expect you to know the x cubed shaped graph. So remember those two. You probably have already from all of the questions you've done before in this video. We also expect you to remember what the 1 over x graph looks like, and this is what the 1 over x graph looks like. Now what happens here is that along this x-axis line here, the graph, the red graph, is going to get very, very close to the x-axis, but it will never actually touch it. 1 over, as x gets bigger, it'll be 1 over something very, very big, which is still actually a positive value. It's never going to be 0. So what we call these to this line here, and actually it's the same for this line here as well, going along the y-axis, is these two are called asymptotes. And you need to remember that name because it could be asked. And the 1 over x squared shaped graph, so this graph is a bit closer to the x-axis. You can clearly see there its closeness to the x-axis is much more, but it's not as close to the y-axis. So it's not reflectionally symmetric from one part of the graph to the other, but it looks like this. Okay, and the same thing here. We've got asymptotes on the x-axis and on the y-axis up there. That's where the graph goes very, very close to that line, but will never, ever touch it. And the final graph we expect you to remember the shape of is the 2 to the x graph. 3 to the x graph is similar but steeper. 5 to the x graph is similar but steeper. 1.5 to the power of x is the same but a little bit shallower, but still go up to infinity. This is what we call the exponential graph. Exponential graph. Okay, and once again we have an asymptote on the left hand side here. Okay, so that's when the x go into the negative values. That's effectively if we had something like 2 to the minus 5, remember from indices that's going to be 1 over 2 to the 5, that's 1 over 32, so it's going to continue and go down into a very small fraction, but it will never actually be a negative value. This graph here is always positive, the y values are always positive. Okay, and what we're going to now consider is graph transformations from those original 5 shaped graphs. So, with a graph like this, what I could think is, well, I could start my shape with the y equals x squared graph. And then I need to think about the graph transformations. So if this is my original function up here, I'm going to be doing f of x plus 3 inside the brackets, and then minus 5 outside the brackets. So this transformation inside the brackets here is going to correspond to moving it left by 3, and this transformation outside the brackets here, the minus 5, will correspond to moving it down by 5. Okay, so this is we imagine the x squared shaped graph. Now we're going to move it left by 3 and down by 5. Doesn't matter what order you do these two things in, because one affects left-right movement and one of them affects up and down movement. So your left and right movement will never get mixed up with the up and down movement. So left 3, down 5. So it's going to look something like that and like that on the right hand side. So its minimum point, it was at 0, 0, had to be moved left by 3 and down by 5, so minus 3. Minus 5 is our answer here, and this is the shape of the graph. Okay, moving on to the next one. So once again, the starting shape of this graph is the x squared graph, but our graph is going to have a transformation of x minus 4 inside the bracket and then plus 9 out of the bracket. And those two transformations mean move it right by 4 and move it up by 9. So take your original y equals x squared shaped graph, move it right by 4 and up by 9, so it looks something like that. So it's going to be at 4, 9, the minimum point. Try and always locate your minimum point when drawing a graph with this kind of technique. Okay, moving on to the next one. So once again, we have a starting shaped graph of x squared, and the transformations that we're going to apply here, -3 inside the brackets and -4 outside the brackets, that means it will move it right by 3 on the x squared graph, and then this -4 here will move it down by 4. So the shape of this graph is going to be x squared, move it right by 3, down by 4, so it's going to look like that. So it's going to have a graph that is at minimum point is at 4, so 3 rather, 3 minus 4. And there we are, that's the minimum point, and that's the shape of the graph. Okay, moving on to the next one. So once again, the starting graph is f of x equals x squared. We will start to change these up soon once we've got a little bit of a practice of moving it around. The next thing we need to consider is what are the transformations. So it's f of x plus 5 inside the bracket and then plus 12 outside the bracket. This one here is going to move it left by 5. Remember, inside the brackets is opposite land, and this value here is going to move it up by 12. So take the x squared graph and move it left by 5 and up by 12. So it looks something like that. 5, 12 is going to be the minimum point, and that's all you need to do. Okay, moving on to the next one now. Now the next one is going to start with the x cubed shaped graph. So f of x equals x cubed in this question. So remember, we need to start with this shaped graph here. Now the transformations that are being applied here is a plus 4 inside the bracket and a minus 5 outside the bracket. And this means we're going to be moving this graph left by 4 and down by 5. Doesn't matter what order we're doing those in because they affect different axes movements. So take your x cubed graph, move it left by 4. Remember, the coordinate we're tracking here is going to be this 0, 0 coordinate. So left by 4 and down by 5. So it's going to look something roughly like that. Left by 4, down by 5. Really probably should have been a bit flatter at that point there. It doesn't necessarily need to go through the 0, 0 coordinate. I don't think it, in fact it does, but that's the rough shape of this graph. It's the x cubed shaped graph, moved left 4 and down 5. Okay, so new question here. What's the parent function going to be? Well, the parent function is going to be x cubed, and what are the transformations? It's going to be minus 2 inside the bracket, and it's going to be plus 4 outside the bracket. So what that means, it's going to move right by 2, and this one is going to be moving it up by 4. Okay, so let's get started on that. Remember, it's the x cubed shaped graph we're moving, so it's going to roughly be that kind of shape there. So it's going to be moving right by 2 and up by 4. So like that. So it's going to have a turning point at 2, 4, because I moved it from 0, 0. So that got moved right by 2 and up by 4. So there we are. Okay, new question. So let's consider what the parent function is going to be. The parent function is going to be x cubed. And what the transformation is going to be? It's going to be x plus 4 inside the bracket and then plus 6 outside the bracket. This is going to mean it's going to move left by 4, and this means here it's going to move up by 6. So let's move it right by 4, the x cubed graph, and then up by 6. Sorry, not up by 6. Left by 4, up by 6. So it's just like that. So minus 4, 6. Right, so moving on to the next question. So we've got this graph here. What's the parent function of this graph? Well, it's going to be the 1 over x graph. So we'll take the function as the 1 over x graph, and we've got plus 3 happening right next to the x, so that will happen inside the bracket, and then the plus 5 is happening on the side, so we'll plus the 5 on the side. And you can then tell what the graph transformations are going to be. They're going to be moved left by 3 and then up by 5. So what we're going to do is we're going to take the 1 over x graph, remember it looks a little bit like that, and we're going to move it left 3 and up 5. Now the best way of doing it is to move the asymptotes first. So we have an asymptote on the y-axis, and that needs to move left by 3. And we've got an asymptote on the x-axis, but that needs to move up by 5. And the graph is going to be formed around those new asymptotes. Just like that. So here is our graph here on the top right, and here on the bottom left. So the parent function here is 1 over x, and we've moved it left by 3, up by 5. Okay, on to the next function. So similar idea here. The parent function here is 1 over x, and the transformations are going to be -6 inside the brackets and then +4 outside the brackets. So we can see here that we're going to be moving this right by 6 and up by 4. So grab your axes, and we'll move the asymptotes first. So it was 1 on the y-axis, now there's going to be 1 at 6, moving it right by 6, and there was 1 on the x-axis, that will move up by 4. So the graph is now going to be in this quadrant and this quadrant. And there we are, that's the answer to this question. Moving on to the next one, once again the parent function here is 1 over x. And the transformations here are going to be +4 inside the brackets and -7 outside the brackets. So let's draw our axes and move the asymptotes first. So we're going to have a left by 4 on one of the axes, and then a down by 7 on the other asymptote. So the first part of the graph is going to appear here, the second part of the graph will appear down here. So there we are, that's the answer to this question. Let's move on to the next one. So this one here, roughly the same, is going to be a parent function of 1 over x, and the transformations that are going to happen here are -3 inside the brackets, and -9 outside the brackets. So this means move it right by 3, and this one here moves it down 9. So draw out your axes, move your axis asymptote, so your y-axis asymptote right by 3, and then your x-axis asymptote down by 9. And then draw your graph around that. So it'll be there, and it will be there. Lovely, moving on to the next one. So this time the parent function is going to be 1 over x squared. Now remember, this graph has a shape of the similar thing to the 1 over x graph on the top right, but then it's going to be on the top left as well. So what are the transformations here going to be? Well, it'll be -3 right next to the x inside the bracket, and then +9 outside the bracket. So that will move right by 3 and up by 9. So let's grab our axes, and we're going to move the x asymptote right by 3, and we're going to move it up by 9. And it's going to be on the top right and on the top left. Lovely, there we are, that's the answer in this question. Moving on to the next one, so same again, the parent function is going to be 1 over x squared, and the transformations here are going to be +5 inside the bracket and +7 outside the bracket. So this function here is going to move it left by 5 and up by 7. So draw your axes, move it left by 5, so draw the asymptote first to get your structure, and then up by 7. So -5 and 7, and then your graph will appear on the top right and on the top left. Okay, next graph. So this parent function is going to be f of x equals 2 to the power of x. And this is going to have a transformation of +4 inside the bracket and +7 on the side. So this is going to move the 2 to the x graph left by 4 and up by 7. So let's draw our axes. And remember, the 2 to the x graph looks like this kind of thing here. So we have one asymptote in the x-axis. So let's move that asymptote first. So that moves up by 7. And and then the graph is also going to move left by 3, so it's going to look something like that. And it'll go down towards the asymptote on this side here. Okay. Moving on to the next one, once again the parent function here is going to be 2 to the power of x, and inside the bracket it's going to be x minus 3, and outside the bracket it's going to be minus 9. So that means it's going to move right by 3 and down by 9. So draw out your axes, and it's going to move down by 9, so we'll have the asymptote move down by 9, and then right by 3, so it's going to stay quite flat for a little bit longer and then start to go up after that. Okay, moving on to the next question. So, in this case, a bit of a different transformation here. It's going to be f of x equals 1 over x. And the transformations here, we're going to have a negative symbol out the front, and we're going to have a plus 3 inside the bracket. Now, what two transformations do we have happening here? They're getting a little bit more complicated now. Well, the one inside the brackets is going to be left by 3, but the one outside the brackets is going to be a reflect up to down, reflect up to down. Okay, so it doesn't matter what order we do those two things in. Let's first move it left by 3, so that would be the asymptote move left by 3 to minus 3, and then we'll reflect it up to down. Now it would be in the top right and the bottom left, but once we've reflected it up to down and down to up, it's going to be in the bottom right quadrant there and the top left quadrant there. So this is the answer to this question. Okay, moving on to the next one. Here the parent function is going to be 1 over x squared. And what transformations do we have going on here? Well, it's going to be a minus symbol at the front, and then x minus 4 inside the brackets. This will move it right by 4, and then it will be a reflect up to down. So, let's draw our axes. It's going to move it right by 4, let's draw those asymptotes, and then it's going to reflect it up to down. Now, the 1 over x squared graph is going to both be on the top, so in this question they're both now going to be on the bottom. So there we are, that's the answer. Okay, moving on to the next one. This time the parent function is going to be f of x equals x squared, and the transformations we're going to have here is a minus symbol at the front, then f of x minus 4 inside the brackets, and then plus 7 outside the brackets afterwards. Now we've got 3 transformations here, 1, 2, and 3. So, it doesn't matter whether we do outside the brackets first or inside the brackets first. Let's move it right by 4 first. The next thing we need to do is we need to do the outside ones. There's 1 inside transformation and 2 outside ones. And the 2 outside ones, it does matter the order that we do these in. This minus here is effectively times by minus 1, so that's a multiply effectively, and that's an add, and we follow the rules of BODMAS. So BODMAS, the minus symbol is effectively a multiply, and the add is effectively an add. So we would do this one first, reflect up to down. And then the last thing we would do is we would then move up by 7. So, we're visualizing the x squared graph at the moment, so it's a smiley face shaped graph. We're going to move it right by 4, that's the first thing we'll do. Then we'll flip it upside down, and then we'll move it up by 9. So it looks like this thing here. So remember, it got moved right by 4, up by 7, so it's going to move to 4, 7 here, but it's a sad face graph due to the negative symbol at the front of that expression. Okay, moving on to the next one. Now, you could treat this graph here as minus x plus 3 squared add 9. Just because the two things are written the other way around doesn't mean that that can't be added at the back. So once again, it's going to be the x squared function that is our parent function. And then after that, it's going to be a minus at the front of the function, x plus 3, and then add 9. So we've got 3 transformations here again. This one inside the brackets is going to be moved left by 3. The one outside the brackets here is going to be a reflect up to down. And then the last transformation we're going to do is this one here, which is move it up by 9. So let's draw our axes. Imagining the y equals x squared shaped graph first. Let's move it now left 3, so it's this kind of shaped graph here. Then we're going to reflect it up to down and down to up. And then we're going to move it up by 9, so it's going to look kind of like that. So it's going to be across here, it got moved left by 3 and then up by 9, and it's reflected due to the negative symbol in front of the x plus 3 squared. Okay, moving on to the next one. So the parent function here is the 2 to the power of x graph. It's always going to be one of those 5 that we have memorized at the start. And what I'll probably do is I'll probably scribble out the 8 and I'll probably put it at the back. So the transformation here is going to be minus f of x plus 8. So 2 transformations here. I reflect up to down and down to up. And then after that it's going to move up 8. So I'm going to draw these in stages, this one. So it would originally be this kind of shaped graph here. The first thing it's going to do is it's going to reflect up to down. And then after that, we're then going to move it up by 8. So we'll move the asymptote first, so that it's still on the x-axis at 8. And it's going to be reflected downwards like that. Now remember, the starting point was this kind of graph here. And this point here is always 0, 1. So that would have got reflected down to 0, minus 1, and now it's been moved up 8, so it would now be at 0, 7. So this axis intercept here we can calculate, it's 0, 7. Okay, let's move on to the next one now. So once again, the parent function here is going to be 2 to the power of x. But this time the negative symbol is inside the bracket, where the x is, right next to the x symbol. And when the transformation is right next to the x symbol, that means it goes inside the bracket when you write down your function notation. Then we're going to take away 3. So we've got 2 transformations here. This one here is going to be a reflect left to right and right to left. And then it's going to be moved down 3 afterwards. So let's do it in stages. We start with the 2 to the x graph. Then we reflect it. So let's do the reflection first, left to right. And then it's going to move down 3, so the final graph is going to look like this. We'll move it down 3 on the asymptote, and it's going to look like that. So it was at 0, 1 to start with here, and we moved it down by 2, so it's now at 0, minus 2. Okay, moving on to the next one. This graph here is going to have a parent function of x squared, and in this case it's going to have a 2 multiplier at the front of the function and then an x minus 5 inside the function, inside the x bracket. So we're going to have 2 transformations here, one that's going to stretch up and down by a scale factor 2 and one that's going to move the graph right by 5. So it's stretched from the x-axis, so if you imagine the x squared graph first, it's going to be stretched upwards by a factor of 2 and then moved right by 5. Still touch that axis exactly at 5, 0. Right then, moving on to the next one. So in this question here, what I'll probably do is I'll probably think about this as 5 times 1 over x plus 9. So that's how I'll think about it. So therefore the parent function of this graph is going to be 1 over x, and therefore the transformation is going to look like 5 times f of x plus 9 on the side. So both of these transformations are outside the brackets. So that means it does order the order that we transform these in. So 5 is going to be first, because that's multiply, and then add will come second. So 5 being the multiply, that will stretch it up by a scale factor 5. And then this one here will move it up by a value 9. So let's just do it in separate stages here. This is our 1 over x graph that we'll begin with. When we times by 5, that's effectively going to stretch it up on the top by a factor of 5 and stretch it down by a factor of 5 on the bottom. Visually, what will happen is the distance to the centre will actually get 5 times further away. So 5 times further away on the bottom, 5 times further away on the top. The final thing we'll need to do here is move it up by 9. So we'll draw our asymptote in first, and then we'll move it up by 9. So still remember it's quite a far away from the center point because it's a 5 times stretch scale factor. So this is the answer here. Okay, moving on to the next one. This function here is going to have a parent function of 1 over x squared. And we can see here the transformation is going to be a 3 multiplying by the x inside the bracket. That 3 is being multiplied straight away to the x. Difference to this function here where it's just 5 times the whole function. This one here is just 3 times the x value. So it's 3 times the x value inside the bracket and then take away 6 afterwards. These are two different transformations, so it doesn't matter which order we effect these in. The 3 is going to squish it inwards by a factor of a third. Remember, inside the brackets is opposite land. And the 6 here is going to move it down by 6. So, therefore, let's do it in stages. This is the 1 over x starting graph. Then what we'll do is we'll squish it inwards by a factor of a third. That's what happens to this, this 3 here. So squish it even more inwards than it was before. And then the last thing we'll do is move it down by 6. So draw in your asymptote first, and then draw your graph second. So make sure it's quite close to the axes here, 3 times closer than it would be on the original graph. Okay, moving on to the next one. The parent function here is going to be the 1 over x graph. And I'm going to think of this as minus 7 times 1 over x plus 3. So here the transformation is going to be minus 7 f of x plus 3. 3 transformations outside the bracket here. First one, reflect. So that's going to reflect it up to down. Then it's going to be stretch by a scale factor 7. These two, doesn't matter what order you do these two in, but you must do this move up by 3 last because it's an addition rather than these two here. Basically both count as multiply. So your 1 over x graph starts out looking like this thing here. The first thing we'll do then is we will reflect. So it's going to move down to up and up to down. The next thing we'll do is we'll times by a scale factor 7. So that's going to stretch it outwards by a scale factor of 7. Whoops, no, I did that wrong, haven't I? Because it was on the top and on the bottom. So it's going to be bottom right and on the top left, but stretched outwards from the centre by a scale factor 7. And the last thing that will happen here is it will move up by 3. So drawing your asymptotes first, and then we're moving this graph up 3. So it's going to be up like that and round like that. So there we are, that's the answer to this question, this graph here. Okay, moving on to the next one then. This graph is going to be f of x. It's going to have a parent function of 1 over x. And the way I'm going to think of this is I'm going to think of it as moving the 4 to the back. So it's going to be minus 5 f of, and then x minus 3 is happening inside the bracket, and then plus 4 on the outside. So 4 different transformations here. Let's do the inside one first. That's left, so right 3. The next thing we'll do is we'll do this minus 5 one. So this is going to be a simultaneous stretch and reflect. So stretch by a scale factor 5 and reflect. So once you've got good at them, you can do the stretch and reflect in the same breath, and then we'll move it up by 4 afterwards. So let's do it in steps. Start with your 1 over x graph, then we'll move it right by 3. So draw an asymptote at 3, and then reflect, and then move it. Then we will do the next one, which is times and reflect. So then it's going to look like, so it's at minus, so we've got the asymptote at 3 still, and it's going to reflect and stretch, so it'll look like that. And the final thing will happen is move it up by 4. So it was moved left by 3 to get started. Then we're going to also move it up by 5, so up by 4. and it's going to be on the bottom right, quite far out from it because it's multiplied by 5, so it's this graph here. So I've broken it down into 4 separate stages, so I can work through each of those stages and visualize it. Right, moving on to the next one, 5 to the power of x. Well, I can just go straight to the answer for this one. It's basically the 2 to the power of x one, just with a scale factor 5 on it, so it's going to increase much quicker. Okay, next graph. This graph is going to have a parent function of x squared. And the way I'm going to think about this is I'm going to choose to move that 7 to the back. So it's going to be minus outside the brackets, then f of 3x inside the bracket, plus 7. So 3 transformations here. This one will squish it inwards by a factor of a third. This one here will reflect it up to down and down to up. And then this final one here will move it up 7. So starting from the x squared graph, it's going to be squished inwards by a factor of a third, so much skinnier. The next thing will happen is it will reflect down to up and up to down. And then the last thing will happen is it will move up by 7, so it'll be up at 7, and it'll be quite a skinny x squared graph like that. Okay, moving on to the next one. This one here is going to have a parent function of x cubed, and I'll move that 9 to the back. So now it's got a transformation of minus f of x minus 4 plus 9. So 3 transformations here. This one will move it right 5. This one here will reflect it up to down and down to up. And this one here will move the graph up by 9 afterwards. So for this difficult one here, we'll start with the x cubed graph. The first thing we'll do is we'll move it right, so right by 4, not 5, silly me. So move it right by 4. The next thing we'll do then is we'll reflect it up to down, down to up. So still going through 4, but like that now. And then the last thing we'll do is we'll move it up by 9. So that turning point is now going to be at 4, 9. And it's going to come down, turn through that point, and then head back downwards. So there we are, that's the answer to this question, this graph here. Okay, moving on to the next one. This parent function here, well, it might as well be 5 to the x. It would be silly if it was 2 to the x, because I can just start with 5 to the x. And the transformations here are going to be a minus x inside the bracket and a plus 6 afterwards. So this one here is going to reflect it left to right and right to left. And then this one here is going to move the graph up by 6. So let's start with the 5 to the x graph. The first thing we'll do is we'll reflect it left to right and right to left. And the last thing we'll do for the final answer is move it up by 6. Let's move that asymptote first so we've got some structure, and then we can reflect it like that. So it's now going to be an x-axis, y-axis intercept at 0, 7. Okay, moving on to the next one. This parent function here is going to be 1 over x. And I'm going to think about moving that 5 to the back. So the transformation is going to be minus 4 f of x minus 7 plus 5. Okay, so let's start with the 1 over x graph. Let's first of all move it right by 7. So asymptote at 7. The next thing we're going to do is we're going to reflect it by minus 4. So that is outside the bracket, that means up and down. Still going to have an asymptote point at 7, but it's going to also stretch out by a factor of 4 as well. Whoops, I didn't do the reflect part of that one. So rub that out, and it's going to reflect onto this side, and it's also going to be on this side here. And I've enlarged it by a scale factor of 4 outwards as well. So that's that, and then the final picture of this graph is now going to be moved up by 5, so an asymptote line at 5, an asymptote line at 7, and it's going to be on the bottom right but quite far out, and it's going to be on the top left but quite far out. So it's this shaped graph here that is the final answer. That there and that there. Okay, moving on to the next question. The parent function here is going to be 1 over x squared. So the transformation is going to be 5 f of x minus 2 plus 6. So in this question here, we'll start with the 1 over x squared graph. Then we're going to move it left by 2. So right by 2, because it's a minus inside the bracket, opposite land. So move it right by 2. The next thing that's going to happen is it's going to stretch out by a scale factor 5. So it's at 2 here, and stretch out by a factor of 5. And the last thing that will happen is it will move up by 6. So draw that asymptote at 2. Draw the next asymptote at 6. And then it's going to be quite outwards up on the top right and on the top left. Whoops, that should be further out, so let's redo that. So it's going to be quite far out. So there we are, this is the graph here. Okay, moving on to the next one. This parent function here is going to be 5 to the power of x. And in this transformation, it's going to be a half x inside the bracket and then plus 4 outside it. I'll probably move that to the back. So in this shape here, we're going to start with 5 to the x. Then this half inside the bracket is going to stretch it outwards by a scale factor of 2. So let's do that first. So it's going to be a little bit flatter than it was before, but still quite steep. And then it's going to move up by 4. So draw an asymptote line at 4, and then it's the graph that's going to be like that. So yeah, there we are. So it's still going to be at 0, 5, because the stretching outwards, left to right, didn't affect this coordinate here at 0, 1. And then we moved it up by 4, it will move to 0, 5. Okay, so for this question here, the parent function is going to be 3 to the power of x. And the transformations here are going to be a minus outside the bracket, and then plus an 8 on the end. So plus 8 like that. So we'll start with doing it in order. You have to do the reflect before the plus 8. The 3 to the x graph looks like that. A little bit steeper than the 2 to the x, but not as steep as 5 to the x. Then we will reflect it up to down. So it's now going to be down like that. This point here will be at 0, minus 1. And then the final thing will happen is it will move up by 8. So draw an asymptote line at 8, and it's going to be reflected downwards like that. So it's going to be now at 0, 7. And there we are, that's the answer. Moving on to the next one, the parent function here is going to again be 3 to the power of x. And the transformations here are going to be 6 f of minus x inside the bracket because the minus is right next to x, and then plus 4. So the 3 transformations here are going to be reflect left to right, right to left, stretch by scale factor 6, up and down, and then after that it will move up 4. So let's go through these transformations. So 3 to the x first, then reflect it left to right, then stretch it up by a scale factor of 6, and then final step will move it up by 4, so an asymptote at 4, and then it's going to come from the right hand side and go up like that. So where's this x-axis intercept ended up? It was at 0, 1 when it reflected left to right, then it moved up to 0, 6, then it moved up by 4, so it's now going to be at 0, 10. Okay, moving on to the next one, 2 sine x. Okay, so we need to remember our sine graph. The sine graph looks like this thing here, and this thing around the back. So if it's now going to be a scale factor of 2 stretched up and down, I might as well just put 2 and minus 2 on my label of my diagram there. Moving on to the next one, cos of 3x. Well, this is going to be the cos graph, but it's going to be squished inwards by a scale factor of 3. So let's draw the original cos graph. The original cos graph would go like that, and then like that. So minus 360, minus 270, minus 180, minus 90, 0, 90, 180, 270, 360. And the answer to this question is it going to be squished in by a scale factor of 3. So it's going to do very quick up and down. So 30, 60, 90, 120. And same on the left hand side, quick up and down, 30, 60, 90, 120, but obviously all negatives. Okay, so there we are, that's the answer to this question. Moving on to the next one then, sine x plus 30. Well, this is going to be the sine x graph moved left by 30. So the original graph looks like this. It went up and down, so down and up. And the answer to this question is it going to be moved left by 30. So it will start here and then up, and then down, up, down. So this is minus 30 here. This peak here, well, it would be at 90, so now it's at 60, but it doesn't look like it. This here is going to be at 180, but now it's going to be at 150. This here is going to be 270, but now it's going to be 240. And this one here was 360, now it's 330. This point here would have been at minus 90, now it's minus 120. And we keep on going back by 90, minus 210. Go back by another 90, minus 300. And then minus 390 for the end point. Moving on to the next one, cos half x. This is going to stretch it out by a scale factor of 2 on the cos graph. So the original cos graph looks like that and then like that. And the answer to this question is going to be stretched outwards by a scale factor of 2. It's a bit more like that. So it was at 0, this point was at 90, now it's 180. This point here was at 180, now it's 360. This is 270, but now it is double that, to 540, and this point over 720, and it's going to be all the negatives on the other side as well. This graph here is going to stretch it up and down by a scale factor of 4, and then move it up by 3. So the original sine graph looks like that and like that. And the answer to this question is it going to be, well, it was stretched up by a scale factor of 4 first. Let's put 4 and a 4 here. And then when I'm going to move it up by 3, it's going to be a little bit underneath, but mostly on top. So it's going to start at 3, go up, then down a little bit, but mostly back up again. So this point here is going to be 3 and 3, so 180. Let's put it down here, 180, 360. And on the right hand side it's going a little bit down, but mostly up and up. So it goes to a minimum point at -1 and a maximum point at 7. Moving on to the next one, 3 minus x. Well, in this case here, let's do it from the parent function, so sine x. And the transformation here is going to be minus f of x plus 3. So it's going to be the, whoops, actually I think I'll break it down a bit more. So it's going to be a negative sine graph, that's up and down reflected. But then it's going to be moved up by 3, so the final answer, well, it was at 1 to -1, so it's at least, this -1 here is going to move up to 2 and up to 4. And it's going to start at 3, and it's going to go down first, then up, then down, and then up, then down, then up. So there we are, that's the answer to this question. Alright, then moving on to the next one. So the parent function here is the cos function. And the transformation here is going to be -2 f of x plus 4. So the -2 multiplier transformation first is going to mean it's going to start off life like this. -2 minimum point, 2 maximum point. But then when it gets moved up by 4, then it's going to have a new minimum at 2, a new maximum at 6, starting at 2, and it's going to go up, then down, And this one's going to go up, then down as well. So there we are, that's the answer to this question. Right, moving on to the next one. The parent function here is sine x. And what type of transformations have we got happening here? Well, it's going to be a negative at the front of the function, 2x inside the function, and then add 5 afterwards. So let's break it down into smaller steps, quite a few smaller steps actually. So the sine graph originally, we'll squish it in by a scale factor of 2. So a little bit more squished in. Now we'll reflect it up and down. And the final thing we'll need to do is then move it up by 5. So it was down at -1 to 1, now it's going to be up at 6 to 4. And it's going to start at 5, going down first, then up, then down. Up first, then down, then up. Like that. Right, okay, this one here is the parent function, so f of x equals tan x. And the only transformation we have here is squishing inwards by a factor of 2. Let's just remind ourselves of what the tan graph originally looked like. The tan graph originally looked like lots of x cubed graphs, but with asymptotes at 90 degrees and every 180 from there, going backwards and forwards. So minus 90, and then this one here is going to be minus 270. So then it would be lots of these type shaped graphs. So this one here is going to get squished inwards by a factor of 2. So this would be at 45 to minus 45. And then the next one, 270, well that would be at 135 and minus 135. And once again, lots of probably skinnier x square, x cubed shaped graphs in there. This one here is going to be the tan graph moved right by 45. So it's the original tan graph, if you remember, was at 90, 270, minus 90, minus 270. And then this is all the x cubed shaped graphs with the asymptotes. So if we move it right by 45, then 90 will now be at 135, 0 will now be at 45, minus 90 will now be at minus 45. So there'll be an asymptote there, and an asymptote there, and a tan graph there. The next thing, and then it would be just be this carrying onwards left to right. So add another 180 on the end there. Grab a calculator, 135 plus 180 gives us 315. And then this going backwards by 180, minus 45 take away 180 gives us minus 225 on the asymptote there. Sine of minus x, well that's the sine graph reflected left to right, right to left, so it's going to go down first then up, and then on the left up first then down. And that's all we're going to do in this selection of questions. So hopefully you found that video useful. Maybe come back to it in about a week's time and maybe have a go at some more of the challenging questions. See if you can identify the parent functions and then original graphs by transformations. Or go all the way back to the roots and go through the roots, y-intercepts, x-axis intercepts, and then what kind of shaped graph it's going to be. So hopefully you found that useful, and yeah, thanks for watching.